Still using nested loops for 2sum? That's an O of n squared solution and barely beats 26%. Instead, use a hash map, let's call it f, where we store the number as the key and the index as the value. Then we iterate through the array and calculate the desired value, which is target minus the current value. If the desired value exists in the hash map, we return the current index and the stored index from the hash map. Otherwise, we add the current value with its index to the hash map. This approach runs in O of n time and beats 100%. That's it. 2sum feels easy, until you're required to solve it in O of n time. That's where 2sum2 comes in, because the input array is already sorted. We use the two-pointer approach. Start with I at index 0, and j at n-1. While I is less than j, calculate the sum. If the sum equals the target, return I plus 1 and j plus 1, since the problem uses 1-based indexing. If the sum is greater than the target, move j left. Otherwise, move I right. If no valid pair exists, simply return -1. This solution runs in O of n time, and easily beats around 80% of submissions. Still using linear search on sorted arrays? That's wasting time. Binary search works only on sorted data and runs in O of log n. We start with 2 pointers, I at low and j at high. Find the middle index, that is I plus j floor divided by 2. If mid equals target, return it. If target is smaller, move j to mid-1. Else, move I to mid+1. Repeat until I is less than j. Each step cuts the search space in half. Fast, clean, efficient. That's it. Still using nested loops in maximum subarray problem? That works, but not efficient. Let's do it with Kadane's algorithm. We start by declaring max sum to -infinite, and current sum equals 0. Then we iterate through the array once and add current element to the current sum. If our current sum is greater than max sum, update it. And if our sum approaches negative, update it to 0, cause including those values will always decrease the max sum. At last, return the max sum. That's it. It's O of n time and too much efficient than previous one. Still using a hash map in Leetcode's majority element problem? That works, but not efficient because it requires O of n log n time and O of n space. Let's solve it using Moore's voting algorithm. We start by declaring a desired element, that will be our answer, equal first element of the array, and count equal 1. Then we iterate through the array once. If the current element equals our desired element, we increase the count by 1. Else, we will decrease the count by 1. And if our count reaches below 0, we update the desired element to be current element and count to 1. That's the game changer. At last, return the desired element. That's it. It's O of n time and constant space. Are you using linear search in finding peak element in an array? That works, but not appropriate as we have to do in log n time. So let's do it using binary search. Yes, binary search. We start by saying I at low and j at high, and while I is smaller equal j, we calc the mid. Here we have to decide which side to go after one iteration. That's the key point. So we go to the side where the adjacent element is greater than the mid. So in code we have done the same, handling the edge cases at starting and at ending. That's log n time with constant space. Hello coders. Let's solve the valid palindrome problem. In this we have to return if the given string is a palindrome or not. So first we create a string C by removing all non-alphanumeric characters from the given string S. Then if C's length is none, we immediately return true because it's obviously a palindrome. Else we create a variable n equal to the length of C. Then we iterate through C until n divided by 2. And if the ith index of C does not match the n-1 minus ith index of C, that's a sign of a non-palindrome, so we return false here. And if it successfully iterates through C without returning, at last we return true. That's it. It's linear time and linear space. That's an interesting problem to solve. We have to return are the given two strings anagram or not. Let's do it with easiest way possible, that is using hash maps. Firstly, if their lengths aren't equal, immediately return false. Else create a hash map f1 and add s's frequency by a very Pythonic way using get method. Similarly for t-string, create a hash map f2. At last simply return as f1 equals to f2. That's it. Let's solve best time to buy and sell stocks problem. On this we have to calculate the maximum profit earned by buying a single stock and selling it on a different day. We start by initializing max profit equals 0 and min price equal price at day 0. Then we iterate through our prices once. Our min price will be min of current price and min price, and profit will be current price minus min price. If the profit is greater than max profit, update the max profit. At last, return the max profit. That's it. It's O of n time and constant space. Let's solve best time to buy and sell stocks 2. In this, we have to return the maximum profit earned by buying multiple stocks on different days and selling them. We start by initializing max profit equal to 0 and a variable price that is previous day's price, equal to price on day 0. Then we iterate through the prices once. The profit will be current price minus price. And if profit is a natural number, we add profit to the max profit. That is, we have sold one stock. And also we will update price equal to current price. At last, just return max profit. That's it. It's O of n time and constant space. Are you using nested loops for container with most water problem? That's not efficient. Let's do it with two-pointer technique. Initialize max area equals 0. Start by I at low and j at high, while I is smaller equal j. Calc the length, breadth, and hence area. Compare the area with max area and update if required. And now, we have to decide which pointer to move, so which is smaller in value, move that. Cause using that value always decrease our answer. At last, simply return max area. That's O of n time and beats around 80%. Are you using linear iteration for calculating exponentiation? Let's do it using binary exponentiation. We start by initializing result equal 1. And while our power is greater than 0, if the power is odd, multiply base by result. And then as default, square the base and halve the power. At last, return result. That works for positive power. But for negative power, we must inverse the power and take the reciprocal of the base. So that's it. Binary exponentiation takes O of log n time and beats 100%. Are you using the square root function to solve the valid perfect square problem? It works, but it's not appropriate according to the problem. Let's solve it using binary search. We start by two pointers, I at 0 and j at n-1. While I is smaller or equal to j, we calculate the mid and also the square of the mid value. If the square of the mid value equals n, we simply return true. Else if the square is greater, we update j to m-1. Otherwise, we update I to m+1. At last, if the loop exits, return false. That's it. It's log n time and beats 100%. Are you using the square root function to solve square root of x problem? It works, but it's not appropriate according to the problem. Let's solve it using binary search. We start by two pointers, I at 0 and j at n-1. While I is smaller or equal to j, we calculate the mid and also the square of mid value. If the square of mid value equals n, we simply return mid. If the square is greater, we update j equals mid-1. Else, update I equals mid+1. At last, if the loop exits, return j, because that's the nearest integer in that case. That's it. It's log n time and beats 100%. Let's solve an easy Leetcode problem. That is, contains duplicates. We are given an array of nums, and we have to return, is there any duplicate in it? So, we start by creating a hash set f. Then we iterate through the array. If the current number is in the set, we return true, or we add that value to the hash set. At last, if the loop ends without returning, we return false. That means there is no duplicates there. That's it. It's O of n time, and beats 100%. Let's solve another Leetcode problem that is contains duplicate 2. In this we have to return if in the given array there is any duplicate whose index difference is smaller or equal to k. We start by creating a hashmap f for storing values as keys and indices as values. Then we iterate through the array. If the current value is in the hashmap, and if the difference between the current index and the stored index is less than or equal to k, we return true. Otherwise, we add the current value and index to the hashmap. At last, if the loop ends without returning, we return false. That's it. It's O of n and linear space. Beats 100%. Let's solve an interesting Leetcode problem. That is subsequence. In this, we have to return if the given string s is a subsequence of t or not. We start by declaring n equal to the length of s and m equal to the length of t, and two pointers I and j equal to 0. Then while I is smaller than n and j is smaller than m, if the ith index of s matches the jth index of t, increment I, and as default, always increment j. When the loop exits, just return if I is equal to n or not, because if s is a subsequence of t, all indices of it will match to t's indices. That's it. It's O of n time and beats 100%. Merging sorted arrays. That's interesting. We start by creating an empty array called merge, and declaring n equal length of nums1, m equal length of nums2, and two pointers I and j at 0. Then while I is smaller than n and j smaller than m, if ith element of nums1 is smaller than jth element of nums2, add ith element of nums1 to merge array and increment I. Else add jth element of nums2 to merge array and increment j. At last, when the loop exits, extend the values of either nums1 or nums2 in the array, because one of them would be some part untraveled. That's it. It's O of n time and linear space.